Presently, the construction industry has shown significant interest in the use of lightweight foam concrete or LFC as a building material. Foam concrete is a new generation of lightweight concrete that is versatile with some attractive characteristics such as its flowability, self-compacting and self-leveling nature, ultra-low density, and high strength-to-weight ratio. However, in the Philippines especially, lightweight composites such as LFC has not yet been able to penetrate the construction market for years. Its adoption to the mainstream still hasn't gained traction due to it being marketed for no specialized purpose or niche and only being branded instead for general uses in which other common staple materials greatly outshine it. But to look further into the matter, we'd want to know the nature of LFC more. What sets it apart? What it is made up of? Lightweight foam concrete is primarily made up of four elements: cement, water, coarse aggregates, usually being sand, and most crucially, foam. An issue we pick up on is the sustainability of sand, more specifically, the sustainability of construction-grade sand. Sand is the second most consumed substance in Earth after water. But all the sand found in the deserts, beaches, and seabeds cannot qualify to be a construction-grade sand. Morphologically, it is too fine and rounded to contribute strength. Thus, all the sand used for constructions of all kinds are mined in the topsoil of the earth. But there is a more underlying issue about LFC that makes it hard to gain traction against regular concrete. It lies in its unspecialized marketing and its struggle to find a niche in the construction market. Nonetheless, the characteristics of lightweight foam concrete still holds promise in one day, establishing it as a material more or just as commodities as regular concrete. And in pursuit of that virtue, Project 1 titled Development of Market-Ready Admixtures in Smart Lightweight Foam Composites with Passive Energy Regulating and Self-Reinforcing Properties from Agro-Industrial Waste for Roof Screeds, Roof Insulation, Ceilings, Walls, and Floor Applications of the Sugar City program is established. This project aims to develop market-ready admixtures and smart, lightweight foam concrete with passive energy regulating and self-reinforcing properties. With Objective 1, to develop market-ready SLS-based and protein-based concrete foaming agents in liquid and powder form. Since the quality of LFC is basically tantamount to the quality of the foam it is composed of, improvement of the foaming agent is the key. These foaming agents will be both of synthetic and non-synthetic nature. The latter is derived from organic waste like chicken feathers and fish waste that contain valuable proteins. Objective 2. To develop smart market-ready LFC for roof insulation, roof screeds, and wall applications with agro-industrial waste. LFC's lack of a niche is now then addressed by making it smart. It will be marketed as roof screeds and insulations and wall and floor applications that possesses smart properties such as bio-self-reinforcement and passive thermal energy regulation. The addition of alkaliphilic calcifying bacteria provides a biological mechanism for self-healing over time, thereby improving the mechanical properties of LFC concrete system. The impregnation of lightweight foam concrete by microencapsulated phase change material induces passive thermal regulation that leads to energy savings from cooling homes and buildings. Objective 3. To develop foam expanded glass aggregates or FEGA, the production of less dense LFC For load-bearing applications, that is greater than or equal to 15 megapascals. The utilization of household and industrial glass waste to make foam expanded glass aggregates for LFC will alleviate its reputable lack of reliable compressive and flexural strength. Ultimately, Objective 4 wraps it all up, as all of these technologies will be assessed by the DPWH Bureau of Research and Standards and showcase the technologies generated in a miniature prototype house. But, have you noticed something? Utilized under all these objectives are valuable agricultural and industrial waste that will help us in achieving our goals. Fortunately for us, these wastes are in great abundance in the Philippines, especially in our region of northern Mindanao. The valorization of this agro-industrial waste in the course of our experiments, instead of it lying around and waiting to be disposed in landfills, means that the project's economic and environmental impact is all the more amplified. Compound this with the rising global population moving into urban areas, incurring more housing demand, incurring greater consumption of cement, that incurs more pollution, as cement production is the third greatest industrial source of carbon dioxide emissions, exacerbating global warming, and so on and on along a vicious cycle. The fact that LFC curbs the consumption of cement by around 20% to 40% and the transportation, labor, and logistic costs are eased by a substantial amount makes the goals of the project all the more significant, promoting environmental sustainability, improving the lives of Filipino people, and in contributing resistance against impending global warming.